information, the electrical, it's called the electrical path that interconnect electronic component. You see, we do have the electronic component is here. All of them are connected through those electric paths, right? It's where they're changing information. And there's component. Those components may be soldered. You see, as those components, you can see all those chipsets are soldered on the motherboard. You see, as you can see, I don't know if you can see all the components you can see inside are soldered on the motherboard or headed using the socket expansion slot and port. You see, such as the microprocessors using the socket. You see, the microprocessor, I'm going to speak about microprocessor, and we have the expansion slot. Those are expansion slots. I don't know if you can see properly. Let me adjust my, yeah. Those are the expansion slots that we're going to be used. I'm going to explain, you see, the purpose of all those expansion. But we do have the expansion slot and we do have the port. Those are the port. All of them are soldered on the motherboard. I'm going to explain as we are going along. And remember, also the motherboard comes with the form factors. If we want to know more, we have to go and read the note. The note explain about the ATX, the note explain about the micro ATX and the ITX factor board that you might found, right? Now, let me quickly go to one of the key element on the motherboard. It's called CPU, Central Processing Unit. This one is considered as the brain of computers, right? Let me remove so that I can show you. You see, unlock, and you can remove this. Yeah. This is the CPU, right? This is the CPU. And now we do have the CPU socket. Let me show you the CPU socket. Let me remove the CPU. Here's the CPU. Yeah. And this is the CPU socket, right? You're gonna find the CPU is the connection in between motherboard and the processor. You see, that is the connector, that is the socket, right? The CPU socket that is connecting motherboard and the processor. Remember, we do have two different types of CPU and socket architecture, right? Quickly, I'm gonna explain about the pin grid array. You see the PGA, pin grid array. That architecture, the pin is on that kind of architecture. You're gonna find that the pin are on the side. You see, those are the pin. I don't know if you can see it properly. You see, we do have the pin. Those are the pin. You see, those are the pin. You must touch them carefully. If one of them broken, so the CPU might become useless. So those are the PGA architecture, where pins are on the underside, right? Underside of the processor package, and is inserted into motherboard CPU socket using ZIF stand for zero infos, all right? Means that as you're going to be inserting it, you don't need to press it hardly. What you have to do, you're going to refer to the amount of force needed to install the CPU into a motherboard socket or slot. Motherboard or CPU slot. That was a PGA. Beside the PGA, we do have what we are calling land grid array, LGA architecture. Here's LGA architecture. You see, we don't have pins on the motherboard, but the pins are on the processor. You see, the pins are on the processor. That's it. The pins or the processor, you might not touch them. If one of them is broken, so that your motherboard become useless, you might not use it, right? That is the LGA, right? And the most of socket comes with the numbers. You see, it's going to be telling you which kind of number is. This is LGA 775, and from there, if you research, it's going to be telling you which kind of microprocessor that must be used this year, right? So that is LGA, and this is the processor. In order for you to insert your processor, remember always about the ZIF. And if you look at there, we do have what we are calling notch. Notch is this space, right? You can see this space here. It's called notch here. So in order for you to insert it, is very easy. Identify the notch, and identify the notch on your socket. You see, just align it softly, properly, all right? You just align your microprocessor, and I'm using this position, all right? Because I'm explaining, I'm recording the reason why I'm using this vertical position. Normally, it should be on horizontal. If I'm in the workshop, right? And you close this cover softly, and you see, this is the lever. You press it softly. You see. There we go. And remember, because I'm explaining, right? And remember always, in the course, they advise that if you are touching inside the computer, what you must do, you must always use anti-static wrist strap when working inside the computer, right? Remember about electrostatic discharge that can cause a permanent damage to electrical component. So you must always, you see, if I'm in the workplace, I'm going to always use my anti-static wrist straps, you see. But as I'm now doing this, recording this video as a part of my skill-based assessment, so, and I don't have one, but I'm going to advise you in the workplace, you must always use that anti-static wrist strap. That was about the microprocessor. Now, remember that as the microprocessor is working, right, and we know the microprocessor comes with the architectures, right? If you want to know, go and read, you're going to find that we do have the different, microprocessor comes with the different number of core, a single core, dual core, triple core, quad core, and so on. Please, if you give yourself time to read, you may find more about the microprocessor, right? Now, as the microprocessor is doing a lot of jobs is here, interpreting all those the instructions, and is producing heat. And we know that one of the enemy of electronic component or microprocessor is the heat. You see, if the microprocessor is overheated, it may affect the performance of your PC. Now, in order for you to keep your computer working as expected, remember, we need the cooling system. Quickly, I'm going to explain about cooling system. As I was explaining earlier, that we know electronic component generate heat, and the computer component perform better when kept cool, right? If too much heat builds up, the computer could crash, or component can be damaged. Therefore, it's imperative that computer be kept cool. In order for us to cool the computer, we do have two type of technology that used. I'm talking about the cooling system technology. We do have what we are calling the active cooling system and the passive one. What is the difference in between the active cooling system and the passive cooling system? Normally, we do have what we are calling heatsink. Here's the heatsink, right? Heatsink. Heatsink is on top of the microprocessor. Here's the microprocessor. Normally, we have to put the thermal paste to allow that there is a contact, you see, a contact between microprocessor and the good contact in microprocessor and the heatsink and the microprocessor, right? This is the heatsink is just to dissipate heat when the microprocessor is working, all right? Now, it depends on how much heat that your chipset or your microprocessor is going to be producing. Now, as the microprocessor is doing a lot of work, means that it's producing too much heat, so that we need what we are calling the active cooling system. What does that mean? Means that we do have the heatsink and we do have the fan, and the fan needs a power in order to produce more pressure to cool down microprocessor when it's working, right? So that we do have what we are calling the active is one, right? Now the active cooling system is going to be on top of microprocessor, that in order for you to bring it back, just identify the holes and adjust your microprocessor. You see, as simple as that, and you must lock it. That's it. That's it. That's it. There we go. Yeah, and identify the power cables. You see, we do have a socket here. It's written CPU fan. Just you connect it here. You connect it here. There we go. You see, that is for your CPU, right? And we do have another fan is here just to maximize. That is going to be this fan is going to taking the hot air and take it out so that our system remain cool, all right? Beside that, beside the cooling system, we may also remember I was explaining about the active is one, and we do have the passive. The passive is where the component does not produce too much heat, and this is one of the examples. If you can see here, you see we do have the heat sink is here. That is kind of the passive cooling system. You see, does not need any power. You see, we don't have any power, any fan to produce more air, fresh air to cool the component down. You see, this one we are using the passive one. It will depend on how much the component is producing. And we said that let's go quickly to see the memory, right? Remember, we do have two types of memory. If you go through the note, it's going to be explaining. We do have the ROM, which stand for read-only memory, and the ROM chips are located on the motherboard, right? And other circuit board and contain instructions that can be directly accessed by CPU. And remember, the instructions stored in ROM include basic operating instructions such as booting the computers and loading the operating systems, right? Remember, we said that ROM is read-only memory, means that ROM is volatile memories, means that once you store your information, even if there is no power, ROM is non-volatile. Non-volatile means that if you store your information in ROM, right, even if there is no power, your information remain always in that specific memories, right? Beside ROM, we do have RAM. RAM stands for random access memory, which is temporary working storage for data and programs that are being accessed by CPU. Unlike ROM, RAM is volatile memory, which means that the content are erased every time the power goes off, right? So you have to make sure that in order for you to keep the content on RAM, the power must always be on. And we know one of the roles that if you do have more RAM in your computer, so obviously the system performance is going to be even higher. You see, more RAM increase the memory capacity of the computer to hold and process program and file. With less RAM, of course, a computer must swap data between RAM and the much slower hard drives. That is, and remember about on the note that you see they've